Good morning, children. Today, in this video, we are going to discuss about Werner's theory, which is very important in coordination compounds. Let me take this one, Werner's theory. What is this Werner's theory? Let me see first of all. Now, he is the Werner's. We propose this theory to explain the structure of coordination compounds. This theory explains the structures of coordination compounds here. Alfred Werner. Next, it is based on the following postulates. What are the postulates? Very, very important. The postulates are very important one for us here. Next, what is the first postulate? Let me see. Metal possess two types of linkages. Okay, the first type is what? First postulate is what? It will possess two types of linkages. It is having two types of linkages. The linkage means here what? Valencies. What is the meaning of linkage here? Valency. Valency means what? Linkage. There are two types of valencies. What I mean to say here, there are two types of valencies are there. One is called what? Primary valency, and the second one is called secondary valency. So primary valency also can be called ionizable, because generally this can be shown by ionic compounds. Therefore, what happened? This valency can be also called what? Ionizable valency. And second one is called secondary valency. This one is called non-ionizable valency. Generally, it is shown by the covalent compounds. Secondary valency generally shown by the covalent compounds, actually. Non-ionizable valency. So, in the postulates, there are first point is what? Every metal will have two types of valencies. What are they? First one is called primary valency, and the second one is called secondary valency. Now let me elaborate this. What is this primary secondary valency in very simple methods. Now primary valency means number of ionic bonds. I told you no, it is ionizable valency means what? It is shown by only ionic compounds. That means if you have one ionic bond, the primary valency is what? 1. If you have 4 ionic bonds, the primary valency will be 4 only, right? And also, for example, if you're unable to find out the number of ionic bonds, you go for oxidation state. So oxidation state is nothing but called primary valency. I will show how to find this primary valency oxidation state by beautiful examples. We'll take that. So what I mean to say is that primary valency means what? We have to take oxidation state. Generally, we have to take oxidation states, isn't it? Next, secondary valency means what we need to take? Number of coordinate bonds. How many day-2 bonds are there? In the last class, we discussed here. Coordination compounds are formed by day-2 bond, coordinate bonds, isn't it? So number of coordinate bonds is equal to, isn't it? Secondary valency. Also, simply we can say coordination number. If you know the coordination number, that will be secondary valency. I will explain this, what is coordination number, how to find out this number of coordinate bonds with the example. So at this time, just remember primary valency means oxidation state, isn't it? Primary valency means oxidation state, and secondary valency means coordination number. Simply you remember like this. Oxidation state means primary valency, and coordination number means what? Secondary valency, right? Now we'll take examples. This example, if I say take what happened, example I can explain very easily for you. Now what I taken here, cobalt, 3 chlorides, 6 ammonias. I have taken 3 chlorides and 6 ammonias. This is the coordination complex compound. Whatever you are observing here, what? It is a coordination complex compound, isn't it? Now see, ionization means what? Nothing but primary valency. Primary valency you are getting here. Now, see. Now, if you observe here what happened, cobalt and the chlorine, they will form ionic bonds here. Between the cobalt and the chlorine, what type of bond you are having here? Ionic bond here. So, how many ionic bonds they can form with cobalt? 3 ionic bonds, right? So, 3 ionic bonds you can get. Now, primary valency in this case, how many? 3 primary valency. Yet the primary valency will be 3, right? Next. Otherwise, you take oxidation state. See how much oxidation state here? 3 plus. 3 plus is the oxidation state. Now primary valency will be 3. Now here also you take negative charges are how many here? 3 negative charges are there. Now 3 negative charges means oxidation state is 3. That means oxidation state you can take in terms of positive or in terms of negative. And both will be equal only. The positive should always be equal to negative. Don't add these two. Don't add 3 plus 3. 6. That is not correct. Either you can take positive charge or you can take negative charge, and both must be what? Equal. Okay, this is what actually primary valency. Next, just now I said no, secondary valency, coordination number of dative bonds. Number of dative bonds means coordination compound bonds here. Now how many it is? 6, isn't it? 6. Now I can write here like this. Cobalt is forming a dative bond with ammonia like this. NH3 is a dative bond actually. In this way, how many it will have? 6 you going to have. 6. I will show that one in the beautiful structure. I will show that how it is. But still I'm writing here what? 6 ammonias will form 6 dative bonds. Now you got an idea, no? What is primary valency? What is secondary valency? Primary valency is nothing but oxidation state. Secondary valency is nothing but here coordination number here. Now here we discuss one more thing also. How many moles of AgCl formed in 1 mole of compound? That also we complete this one. Now, if I treat this one with what? AgNO3. Okay. If I treat this one with what? AgNO3. I'm treating this one with what? AgNO3. Now, remember this AgNO3 does not react with this ammonia. Why? Because it is what? Covalent compound. So, AgNO3 is ionic compound. This is what? Ag plus NO3 minus. This is ionic compound. Ionic compound never react with what? Covalent. This is covalent. That means dative bond, nothing but covalent only. And this one is what actually? Ionic. So ionic never react with the covalent. Now this is ionic. 3Cl minus ionic. Now AgCl formed. 3 moles of AgNO3 will undergo. Because if you have 3 Cls, 3 moles of AgNO3 react. If you have 2 Cl minus, 2 moles of AgNO3 reacts here. Now what we get here? 3 moles of AgCl will be formed. How many? 3 moles of AgCl will be formed. Now total number of ions will be how many here? See, this is completely 1 ion. This one is completely 1 ion actually, isn't it? This one is completely 1 ion. Completely this one is 1 ion. And here how many these are actually? 3. Now 3 plus 1 is equal to 4. Total number of ions are how many? 4 ions. We'll take one more example. COCl3, 5 moles of ammonia. Now, see, in this coordination number must be 6 because it's a octahedral. The coordination number must be 6. But how many you are having ammonia? Only 5. Now, what we'll do here? One of the chlorine you take here, isn't it? One of the chlorine you take here. Let me see how it is. See. So, one of the chlorine we are taking inside the complex compound. One of the chlorine you are taking inside the compound. Why? Because you have to maintain 6 as a coordination number here. Now here, this Cl, isn't it, will definitely form a covalent dative bond. This will form a dative bond and also what? Ionic bond. Because it's ionic compound, no, it will form one dative bond as well as one ionic bond. Now chlorine is forming one dative bond and one ionic bond it is forming. Right. Now let me see here. Now how many chlorides are outside? This chlorine once comes into the inside, what happened? It never be dissociated because I told you in the last class, coordination compounds when you dissolve in the water, it never dissociate into simplest ions, isn't it? So the once you place chlorine inside the sphere, it will act as a coordination sphere. It never undergo dissociation, so it will remain in the coordination complex. Now these two Cl minus will react with what? AgNO3, and it will form how many moles of AgCl here? 2 moles of, isn't it? It will form 2 moles of AgCl. Now, how many number of ions we are going to get here? Here you see, observe here what happened. Here 2 ions are there. Here 1 ion is there. I will drop this one, everything. Okay. Here what happened? 2 ions are there here. Here how many? Total how many? You don't take this one as a 2. It's a charge actually. Remember this is charge, not ion. So total it is what? 1 ion, isn't it? It is only 1 ion. So 1 plus 2 is equal to 3 ions we are going to get. We'll take one more example now. We'll take one more example. COCl3, 4 moles of ammonia. Now coordination must be 6 here. So what we do? 2 chlorines are acting as here dative bond as well as what here? as well as what? Ionic bond also. How many? 2 chlorine atoms now acting as ionic and as well as what? Day 2 bond. How to represent this one? You observe here. 2 chlorines. See, acting as what? Day 2 and also what? Ionic. Okay, right. Now here, again what happened? How many AgCl will undergo reaction here? Only one AgN. One Ag is NO3 undergo reaction. One AgNO3 undergo reaction to form here what? AgCl. Now how many AgCl we get? Only one AgCl. And total number of ions are how many here? One ion is there. And everything is what here? Ion only. Only one ion only. So 1 plus 1 is equal to 2 ions it is. Isn't it? Let me take the last one here. Last one. Now if you observe what happened here, coordination number must be 6 here, but only 3 ammonias are there. What actually we have to do? We have to take 3 chlorines inside the coordination complex compound, isn't it? To make coordination number equal to 6. Now we got coordination number equal to 3 plus 3 equal to 6. Now here, these 3 chlorines are acting as what? Ionic and as well as what here? 3 day 2 bonds, 3 coordinate bonds here they are acting, coordinate bonds actually, isn't it? So here, do you have any chlorines outside here? We don't have any chlorine outside. You observe here what happened. Do you have any chlorine outside here? No chlorine outside here. So even though if you treat this one with AgNO3, you are not getting any reaction. So how many AgCls we get here? 0 number of AgCls you are getting. And how many total number of ions? 0. Because you observe here, you have any charge here? This is not having any charge. Remember, it is not having any type of charge here. Chargeless it is. So if you have chargeless, that is called neutral molecule. So total number of ions are nothing but 0, isn't it? See, this is very, very important for examination point of view. How many moles of AgCl will be precipitated, isn't it? They are asking in examination, either in MCQs, otherwise what happened? 1 mark question, isn't it? So how to make answer? Very simple, isn't it? By seeing the structure. They don't give this like this. If they give what happened, you can easily find out. If they given like this, you can easily find out. But they don't give in this manner. They will give in this manner. Remember, they will give in this manner. Now, what you have to do, take the coordination must be number 6. Okay, already 6 are there. So 3 chlorines are outside. So we get 3 moles of AgCl here. Now 5 moles of ammonia is there. Put 1 chlorine here. Okay. Then we get remaining 2 chlorines will be outside here. So 2 moles of AgCl we get. And 4 moles of ammonia is there. We need 2 more actually. So take 2 from this one. So we get only 1 chloride outside here. So we get 1 mole of AgCl. Now in the case of this one, 3 moles of ammonia is there. Now take the help of 3 chlorines to form what? Day 2 bond here, coordinate bond here. So outside we don't have any chlorine, therefore 0 moles of AgCl will be formed, right? So this is about the Werner's theory, and now I will explain the structure now. Now let me take first one more thing actually. It's always the charge of the cobalt in all these things, the charge of the cobalt is how much? +3. You see, ammonia is a chargeless. Ammonia, the charge of ammonia will be 0. Okay. Now 3 chlorines -3. Now cobalt will be +3. 3 chlorines -3. The cobalt will be +. In all the cases, the cobalt is +3 and the 3 chlorines are having -2. Charge will be what here? +3. Oxidation state is what? +3. Primary valency in all these cases, how much it is? All these, the primary valency will be 3 only. And what is secondary valency? See, 6. Coordination number 5 plus 1 6, 4 plus 2 6, 3 plus 3 6. So always the coordination number will be 6 here. So this table is very, very important. Once you watch on the YouTube, you just take this table in your notebook. Take this table. All of you have to take the table out in your notebook and you have to submit in the Google Classroom here. Right? So you have to observe here 3 CLs like this. Primary valency of metal can be vary, but secondary valency always remains same. You see, primary valency actually in this case actually the primary valency of metal is same only, that is +3 only, 3 only. Secondary valency remains same, but in this case what happened? The primary valency is same and the secondary valency is same. But thing is that what actually now this chlorine is 3 chlorines are only primary valence, right? In this case, one of the chlorine acting as primary as well as secondary. That I want to mention here. That is changing only here. In this case, what happened? One is primary only. This chlorine is acting as only primary valency only. But here, these 2 chlorines acting as both primary end as well as secondary valency. So here one chlorine is acting as what? Primary and secondary valency. Here two chlorines are acting as primary and secondary valency. Here three chlorines are acting as what? Primary and secondary. In this way, you have to consider this one. Okay. So whenever if an ion forming an ion, I'm saying whenever if an ion forming, ion means what happened? Negative charge. Most of the case negative charge. Forming a coordination number. That means what happened? Forming a coordinate bond, day2 bond. It can act as both primary valency and secondary valency. Understood here? You take what? Every metal has tendency to satisfy both primary and secondary valency. You just observe here what happened. Every metal means what happened? This is observe. Cobalt. Cobalt is accepting the primary valency with chlorine, secondary valency with ammonia. So it can accept both primary and secondary valencies here. So primary valency means you can take positive ion, that means cation you can accept, negative ion. Many of the cases what happen, it will be negative. Okay. Only we have 3-4 examples for the positive. Take, for example, Ag plus cation, Cl minus anion, Fe plus 2 cation, anion. Like this, we can take number of examples as a primary. Now, secondary valency can be taken as a negative charge, like Cl minus. Just now we have taken the Cl minus as a secondary valency. Neutral mole. Most of the case we observe neutral molecules. Example, ammonia. Just now you've seen this one. Ammonia as acting as secondary valencies, isn't it? 3 moles of ammonia, 6 moles of ammonia. Even if you take what positive, only few examples are there for the positive. So very less examples will be there positive. What I mean to say, primary valencies are only cations and anions, whereas secondary valencies you can take anything. You can take cation, or you can take anion, you can take neutral molecule, you can take positive. This may be also in MCQ you may get like this type of questions. Following which can act as primary valency, does not act as a primary valency. Cation, anion, neutral molecule, none of the above like that. So neutral molecule never act as primary valency. Similarly, following which can act as a secondary valency, negative, neutral, positive, none of the above, all of the above. So all of the above will be the answer. In this way, you have to remember the valencies of, isn't it, Werner's theory, primary, secondary valencies. Once you forget this one, remaining will be very simple. Now we will take one example here. Now I have taken what a coordination compound. This is the coordination compound. Now how you call this one a coordination compound? Because ammonia is formed a day2 bond with cobalt. It is forming a day2 bond with the cobalt actually. Now this one I am dissolving in the water. This one I am dissolving in the water. Now what happens here? Now it will dissociate whichever you are having outside counter ions. For this one, outside counter ion is what? 3 moles of Cl minus. Now this will dissociate, not which are present in the sphere, complex sphere, whatever they don't dissociate, remember. Only which are outer sphere, they undergo dissociation. This is a complex compound. This one is called complex compound actually. It's not dissociating here. Then it is stable now. Now this one is called actually ligand. This we discuss what is ligand definition. Next slides we discuss that one. Ligand it is. Okay. Now let me take the structure of this one. Cobalt. How many ammonias are there here? 6 ammonias are there. Now 6 ammonias are forming day2 bond here, right? 6 ammonias are forming day2 bond like this here. Like this, it is forming day2 bond, right? Now what about the chlorine? They are present outside of the sphere. I will show outside of the sphere how it looks. You observe here what happened. Now one more thing I forgotten here, how it is shown. The secondary valence is shown by the arrow mark, like thick lines, arrow mark. You see this arrow mark, if you observe, that is nothing but day2 bond, right? Day2 bond, thick lines like this. Now how to show the primary valency? Dotted lines. You observe here, this one is a dotted line here. Observing here, dotted lines. Dotted lines are nothing but called primary valencies, isn't it? So primary valence is shown by dotted lines, whereas secondary valence is shown by what here? Thick lines, otherwise arrow mark, right? Now you observe here what happened. Cobalt is a central atom. Okay. Now this ammonia is forming coordinate bond. Cl is forming ionic bond. Now, so whatever you are showing this round sphere, no, that is called inner sphere, isn't it? This one is what? Outer sphere. Now outer sphere contains what here? Ionic bonds. Ionic bonds. See? Ionic bonds. Inner sphere contains what here? Coordinate covalent bonds, day2 bonds, isn't it? This is what? Coordination sphere. This one, whatever ammonia you are observing, no, this one is called coordination sphere. If I call what coordination sphere means, what you have to observe, that is nothing but what the sphere which is formed by the day-2 bonds, nothing but called coordination sphere actually, isn't it? This one is called ionic sphere because this bond is what type of bond you are getting with chlorines here, ionic bond you are getting, therefore it is called ionic bond. So this sphere is because of what actually? This sphere because of what? Coordination bonds, therefore it is called coordination sphere. And this sphere is what? Ionic sphere because it is forming what? Ionic bonds actually, right? Observe here this one. So you should have some differentiation. What is ionic sphere and what is coordination sphere? Now this one you see, this one is what? Ionic sphere. This one is what? Coordination sphere. Understood here? Right. Next we move to what? Next slide here. Structures of coordination compounds on the basis of Werner's theory. Okay. Now see COCl3. Just now we taken COCl3, 6 moles of ammonia. Now all the already coordination number we can make like cobalt, ammonia taken what? 6 times. We don't need chlorine now. We don't need the help of the chlorine because already coordination number is 6 satisfied here. So 3 chlorines are act as what here? Primary valencies. This one is a primary valency. This one is what? Primary. This one is what here? Secondary valency. Thick lines are nothing but here? Secondary valency. Thick lines are nothing but secondary valency. Dotted lines are nothing but here? Primary valency. This is the structure of what? Isn't it? COCl3, 6 moles of IUPAC nomenclature we'll discuss in the next videos. Right? Now let me take what? Next one. Next one let me take it. This structure let me take it. Now here. So this is primary valence. You observe here 5 ammonias are there. So one of the chlorine will act as what? Primary and secondary. I am writing here. One chlorine act as both primary and as well as secondary valency to make what? Coordination number equal to 6 here, octahedral complex compound. Now this chlorine is forming what? Both primary valency and secondary. This is only secondary valency. This one is primary, only primary here. This is secondary valency, secondary valency, secondary valency, primary valency, secondary valency. Okay. Now how to make the formula here? See here. This is the formula. Very simple formula. Now this will form 2 moles of AgCl. This will form 3 moles of AgCl. Next we'll take one more thing. One more thing if you take. Now 4 only are there. First you have to consider this one. 4 moles of ammonia. Okay. Then you take from the chlorine here to help take the 2 chlorines help now here to make the primary secondary valence. Now 2 chlorines are acting as primary, and this one is acting as secondary. This one acting as only primary. Sorry, only secondary. This one is only primary, secondary, it is, and it is also what? Secondary. Now how to make the structure here? This is the way we can make. So how many AgCls we get here? When you treat with AgNO3, 1 mole of AgCl. Next, if you take finally this one, so we have to take these 3 chlorines as what? Coordination number. So 3 chlorines will act as, these 3 chlorines will act as what? Both primary and secondary, primary and secondary, primary and secondary. And this is acting as only secondary valency, secondary valency, secondary valency. With this, what happened? The structures. How to make the structure here? In this way. Does it form any type of AgCl now? No AgCl will form here, isn't it? When you treat with AgNO3, we don't get any number of what? AgCls. So based upon ionizability, some complex compounds exhibit some colors also. Okay, because of their ionization. Let me see the colors also now. If I take what happened? This one. This will show what? Leave it this one. This one will show what? Yellow color. If I take this one chlorine inside, this will show purple color. Next. If I take this one, this will show the green color. If I take this one, this will show the violet color. Now observe here, both are the molecular formula, both of these one will be same here. See, this is having 4 moles of ammonia. And this one is also having 4 moles of ammonia and 2 moles. Both structures are same only. But one is showing green color, other is showing what? Violet color. The reason behind this one is a trans isomer. This one is a cis isomer. Now, what is the meaning of trans means? These chlorines you observe here will opposite side. Then they are called trans. If these chlorines are same side, they are called cis isomers, right? So that is no need for us, because in the syllabus also we don't have the cis and trans isomers. Isomerism is not there. Now one more thing, if you observe here what happened. One more thing. Now how many ions we are getting? 3 ions here and 1. Everything is what? Only 1 ion. If I write O minus 2, do you have 2 ions? No, only 1 ion only. But charge is what? 2. Remember that one. So the total 1, 4 ions. Here 1, 2, here 1, 3 ions. Here 1, this one will be 1, 2 ions. Same like this, isn't it? This is about the, isn't it? Werner's theory. Let me take some MCQs also here. Secondary valency of metal can be satisfied by. If anybody is online, anybody join, you can answer.
Sir, all of this?
Secondary valency of metal can be satisfied by negative ion, positive ion, neutral molecule. All of them will be answer here. So the following is green colored. Can you say that one? Green color. Cis or trans isomer? Okay, no problem, no problem. You can't remember that one.
Sir, trans isomer.
Yes, yes.
Trans isomer.
But actually what happened? This also will have green color, but see, this is not very difficult to remember because of hydrous nature. It will have, because it is also will form actually. This is no need for, but you can remember trans, no problem. According to the textbook NCERT, this one is okay for you. This is no need for it. This is about the Werner's theory actually, right? So you have to watch again this video. Again, if you have any doubts, it will be clear for you.